Today we shall continue with our episode on statistics for beginners. In our last video, we are able to talk about the mean, and I was able to give you some examples on how to calculate the mean. If you check the description below, you are going to see the link on how to watch the video on the mean. If this is your first time of watching my video, please do subscribe so that you can get information on my episodes. Now today we are going to talk about how to calculate the median of ungrouped data, the median of the ungrouped data. First thing I would like to talk about is that don't forget that median is the same thing. When we talk about the word median, is the same thing as middle value. There is another name for median, which is also known as what? The middle value. So whenever we are asked to calculate median, what will come straight to your mind is that we want to calculate the middle value. And there's a technique that you really need to know, okay? And the technique is that if you have to calculate median of any number, there's a need to rearrange the data set given, okay? Rearranging the data set given. So the rearranging of the data set can be in two ways. It can either be in ascending order, or it can be in what? Descending order. What do we mean by the word ascending order? When we talk about the word ascending order, this is arranging numbers from the smallest to the biggest value, okay? From the smallest to the biggest value. And in descending, it's just the other way around. This is from the biggest value to the what? To the smallest value. So I'm going to give you an example to illustrate this. Now let's consider our example 1. In our example 1, we are given the following data set, and we are expected to find what? The median. Don't forget, another name for median is the middle value. So here we have our data to be 2, 3, 9, 1, 8, 6, 7. So the first thing we are going to do, if you are to solve this, is to find them, is to rearrange, okay? Let's decide to rearrange in ascending order here. That means we are picking from the smallest value to the biggest value. And from here, the smallest value we have here is 1, right? So we are writing 1, followed by 2. Then we have 3. We have, there's no 4. Then we move to 6. We move to 7. We move to 8. Then lastly, we have 9. So for us to determine the middle value here, there's a technique we are going to adopt, and this is the technique. So you are cancelling from both sides. Now let me cancel the first value at the left hand side. I'm cancelling the value from the right hand side too. So that is gone. Then we move to the next one, cancel it out. We move to the next one, cancel it out, and we are left with a value at the middle. So the middle value is our median. So that's what we are interested in. So from this, we know that our median is going to be 6. So this is the value for our median. One thing you will observe here is that if you look at the number of observations or data that we have, you will observe that it is odd number. Let's count 1, 2, 3, 4, 5, 6, 7. But in the case that we are having even numbers, this is quite different. So in the case of even number, here we are making use of average of the two middle values. So I'm going to give you an example to show that. So let's call that example 2. So in our example 2, let's have different data set entirely. So we have 2, 8, 6, 3, 1, 9, 0, and 5. Let's count the number of digits we have. 1, 2, 3, 4, 5, 6, 7, 8. Good. That's even number. So now we are to calculate the median of this number. We have to calculate the median of this number. So the first thing to do, as usual, is to rearrange. We can decide to arrange in ascending order or descending. But in this question, we should use descending order. So let's go to, in this example 1, we've used ascending order. So for the example 2, let's decide to use the descending order. So using the descending order, that means from the highest to the lowest. And here the highest is 9. So we are having 9. Then followed by 8, okay, followed by 6, followed by 5, then 3, then 2, then 1, and 0. Let's count to be sure that we have the same digit. 1, 2, 3, 4, 5, 6, 7, 8. Good. If you use ascending order, you're still going to get the same answer. Just to show that, okay, either way, you're still going to get the same answer. Now, let's cancel out as usual. We are cancelling this first here. We cancel out the first here. Then we cancel out the second. We cancel out this. Then we cancel out the third. We cancel out this. And look at it. We are having 2 digits. Okay, 2 values at the middle. So it's quite different from you having a single value here, which is 6. But here we are having 5 and 3. Like what I told you earlier on, we are calculating the average. Okay, and don't forget, in our last video, we talked about how to calculate the average. That means addition of these 2, okay, over 2. So the average is addition of this over 2. And 5 plus 3 is going to give us what? 8 over 2, which is equals to what? 4. So this is our middle value. So this is our median. So we are going to stop here. And in our next video, we are going to look at how to calculate the median of ungrouped data. Okay, this is when you have frequencies and it involves formula. You can say that statistics is very interesting. There's nothing difficult in it. In order for you to follow, to gain notification for our next video, please don't forget to subscribe to this channel and also share this video. Your comments will be appreciated as well. If you have something for us, maybe a recommendation or what you want us to develop on, we are going to appreciate you. Thank you very much. See you in next video. Hello viewers, welcome to Ajadi Math class. Today we'll be working on statistics. Hello viewers, welcome to Ajadi Math class. If this is the first time of watching our videos, please don't forget to subscribe, like, comment, and also share our videos on various platforms. Now, the first slide here, we'll be talking about the use of statistics and in regards to the central tendency, which includes the mean, the median, and the mode. And the formula for calculating the mean, which is also known as the average of observation over time, is being shown here. We talk about the weighted mean and also the combined mean. And in addition to that, we talk about the median, which is the middle value, okay, in a distribution here. This is the mean deviation about the mean, and also about the median is shown here. And in addition to that, we talk about the variance. This is the formula for calculating the variance. For statistical data, we have the group data, and we also have the ungrouped data. Don't forget that variance is the measure of dispersion. Is not a measure of what location. So these are the properties for calculating the expected value of our x and also the variance of our x. The expected value of our x is the same thing as the mean value, while the variance is the measure of dispersion. So this is the formula for calculating the standard deviation and also the binomial distribution, and also the Poisson distribution formula was also shown on this slide. Yeah, in this next slide, we talk about the application of the standard deviation, how the standard deviation can be calculated. That was shown in the first example, and also in the second example, we talk about it shows how the mean can be calculated. And the last example, we talk about the variance of an observation, how it can be calculated, the application of it. And in this new slide, also this is another example to show how the mean, the median, the mode and variance of can be calculated using the example given to us here. You can pause the video to go through the examples and how the examples was used. We can see there are two different formulas for calculating when we have the group data and also for the ungrouped data. And here we talk about the measure of central tendency. You can pause the video to see what the measure of central tendency really entails. So we talk about the mean, which is the arithmetic mean, the arithmetic mean, which is the average of all the observations. Okay, we add the observations together over the number of or at times we use the summation of our frequency, summation of f. So that can be used, and these are the properties of mean that must be followed in calculating the mean. Okay, in calculating the mean, you must also always know the total, okay, and also the number of observation, and the minimum and the maximum value should also be known. Don't forget that mean can be used to make general assumptions over our data sets. Okay, and this is another example showing how the geometric mean can be applied. And there's what we call the assumed mean. The assumed mean is just a value that is being used as our mean, and it will be the deviation is going to be used in calculating the original mean. So we have the geometric mean for the ungrouped data and also the geometric for the grouped data. For these, we have, this is the combined mean. Okay, there's what we call a combined mean. The first on this slide, an example was shown on how to make use of the geometric mean in calculating the values using the formula given in the previous slide. And here we talk about the formula for the harmonic mean, also for the ungrouped data and also for the group data. In calculating the harmonic mean of a data set or of an observation which ranges from x1 to xn, is more or less like you finding the reciprocal of each of the observation. Okay, so that is the n, which is the number of observation, over the reciprocal of each of the observation. And this is the relationship that exists between the arithmetic mean, the geometric mean, and also the harmonic mean. So we can easily see the relationship that exists between the three formulas. Okay, and from here we can know that the arithmetic mean is greater than geometric mean, greater or equals to, while the geometric mean is also greater or equals to the harmonic mean. Here we talk about the median. The median is the middle value of an observation. There are some cases whereby we have it for the odd numbers and also some cases for the what? For the even numbers. So there are two different formulas for calculating the median, that is for the group data and also for the ungrouped data. So the formula is quite different. So this has been shown in this slide, and also in the next slide here we'll talk about the mode. Mode is the most occurrence of an observation. We can see that we also have the mode for the group data and also for the ungrouped data. For the group data, you just pick the most occurrence, and for the ungrouped data, you pick the most occurrence. And also for the group data, there's a formula that must be used, and the breakdown of the formula is shown on this slide. And here we talk about the mean deviation, which is the deviation of an observation from the average. Okay, we want to see how far the observation is from the average. So this is shown for the mean deviation. So looking at an example or the formula shown on this slide, we can have a clear view of the mean deviation for the ungrouped data and also for the group data. And here we talk about the standard deviation. So there is a direct method for calculating the standard deviation, and it is shown on this. And also there is a shortcut which is faster by making use of the assumed mean approach. And take note that standard deviation has its own formula for the group data and also for the ungrouped data. This should be put into consideration in learning the standard deviation. And there's what we call the combined standard deviation also, so which is also shown here. In regarding to standard deviation, don't forget, like I said earlier, standard deviation is a measure of dispersion. Okay, we want to see how dispersed the data set is. So it helps in making decision. Yes, also in statistics. And lastly here, this is the formula for the coefficient of variation. Yeah, the coefficient of variation is the standard deviation over the mean times 100. Okay, standard deviation over the mean times 100. So this is the formula for calculating the coefficient of variation. And what is the use of coefficient of variation? Okay, we use when we talk about the variation statistics, it's believed that no two things is exactly the same, so it is used. So you can take your hands on some of these other formula also. This is being shown from a textbook. You can have a clear view, pause the video, zoom it, just to have a clear view of how this formula works out. So from this inequality involving the arithmetic mean, geometric mean, and also the harmonic mean. And these are various examples that you can put your hands on to have a clear view of how this thing occur. These are the fundamentals of statistics. If you have good knowledge about this, then that shows that you have the background knowledge of statistics. And please, while watching this video, don't forget to click on the subscribe button on our YouTube. So our YouTube channel is Ajadi Math Class, and on Facebook, Mathematics Series. That is our page on Facebook. Just click on it. See you next video. Thank you very much for subscribing to our YouTube channel and also for watching our videos. I hope this helps. Hello viewers, welcome to Ajadi Math Class. Today we shall continue with our series on statistics for beginners. So today we are going to be working on the mean and the median of grouped data. Yeah, in our last video, we've been able to talk about mean and median of ungrouped data. So today we are moving straight to the group data. Now, looking at the question given to us here, we have these observations being grouped as shown here, and we have the frequency for each of it. Now, what we are expected to do is to calculate the mean, and don't forget from the definition of the mean that calculating the mean, we have that the mean is the formula for calculating the mean. We have it to be summation of x over summation f. This means that the summation of that is the plural of the frequency and the midpoint x, so which is what, fx. So we are going to get the summation and divided by the summation of this frequency. Now the first thing we are going to do is to calculate the summation of our frequency, and from here we know that our summation of our frequency is addition of everything. We have 3 plus 5 plus 6 plus 7 plus 9 plus 8 and 7. This is going to give us 38. That is the summation of our frequency. Now calculating our midpoint, because the midpoint is going to stand for our score. So calculating the midpoint between 40 and 49, just on a rough sketch, if you have 40 plus 49 over 2, and that's going to give us what? 89 over 2, and that's going to give us 44.5. So the midpoint of this is going to be 44.5. Calculating the midpoint for 50 to 59 is going to give us what? 54.5. This is easy to know, just add 10 to it, since it is at equal interval. And this is going to give us 74.5. This is going to give us 84.5. And this is going to give us 94.5. So that is our midpoint. Now the next thing for us to do is to calculate our fx. That is the product of our frequency and the midpoint x. So 3 times 44.5 is going to give us, you can use your calculator for confirmation of this. This is going to give us 133.5. And 5 times 54.5 is going to give us 272.5. 6 times 64.5 is going to give us 387. 9 times 74.5 is going to give us 670.5. And 8 times 84.5 is going to give us 676. And lastly, 7 times 94.5 is going to give us 665. Okay? So, adding this together, the summation of our fx, this plus this, plus this, plus this, in total is going to give us 2,804.5. So this is our fx. So this is going to stand for our what? Summation fx. So calculating the mean here, we have that our summation fx, which is 2,804.5, divided by our summation f, which is 38. So this is going to give us 73.8. This is our mean. So this is the average for these data sets. So you can see that the method of group data is quite different from the method of ungroup data, being that here we need to calculate our midpoint because we need to know the average observation for this range of values. So this is mean. Now we are going to move straight to median of group data. And for calculating the median of group data, it has a formula, and the formula is easy to know. Yes, it is very easy to know. And for that, let me change my pen here. Yeah, let me change to red. So, for our median, we are going to make use of this formula. Let me make it thick. Yeah. So, we are using this LB subscript B plus N over 2 minus cumulative frequency before the median class times the class width all over the frequency of the median class. Now, I'm going to say the meaning of all this. Here, we have that our LB okay. So here we have that our LB, L subscript B, is the lower limit of the median class. Is the lower limit of the median class. And our N is the number of observation. Okay? We have that as our number of observation. We have our CFB to be the cumulative frequency before our median class. Okay? So this is the cumulative frequency before the median class. Sorry for using abbreviation. And we have our F subscript M, which is the frequency of the median class. So it's the frequency of our median class. And lastly, we have C, which is the class width, or let me say class size. Yeah, let's call this class size. Yeah, looking at this, from here, we know that our lower limit, the first thing for us to determine is to determine our median class. And for you to determine your median class, in our last video, you can check, we talk about how to determine median, okay, from group data. Now, the summation F we have here is 38. So when you divide 38 over 2, it's going to give us 19, right? So let's calculate our cumulative frequency and let's see first. So our cumulative frequency means addition of the subsequent frequencies. And here we have 3, starting with 3. Sorry. And next we have 3 plus 5, right? We have 3 plus the next value, which is 5. So that's going to give us what? Let me put it this way, that we have 3 plus 5, which is going to give us 8. And next one, we have the previous value, which is 8 plus 6, right? Sorry. And which is going to give us 14. So subsequently like that, 14 plus 9 is going to give us 23. 23 plus the next value, which is 8. Okay? Next frequency value, which is going to give us 31. And to the last value, which is 7, is going to give us 38. So this is going to give us 38. Now let's check. Since our summation F is 38. Okay, so our median class is going to be less over 2, which is 19th value. So where does our 19th value fall? So we can see that it falls on this region. Yes, it falls on this region. So this is going to be our what? Our median class. Let me change the pen so we can see what we mean by the median class. So our median class is going to be this. So which is this? Straight down like this. So it's 70 to 79. So looking at this now, what is going to be our lower limit? So our lower limit is 70, while upper limit is 79. So our lower limit is 70, right? And our number of observation from 40 to 49. Students often make mistake here whereby saying that 40 to 49 is 9. No. So 40 to 49 is 10. We have 10 digits. Okay, when you count from 40 to 49. So here we can say that our n is 10. And the cumulative frequency before the median class. Since this is our median class, so the cumulative frequency before it is what? 14. Okay? That is our cumulative frequency before it. We have it to be what? 14. And lastly, we have our frequency. Our frequency of the median class. So the frequency, since this is the median class, the frequency of the median class is 9. Okay? So the frequency of the median class is 9. While our class size is 10. Oh, sorry. Our number of observation can be 10. That is a mistake from my part. It's 38. Okay, our number of observation is the same thing as summation F. Okay, now doing this, we are going to make use of these values in computing our median. So coming down here, we have that our median will now be equal our lower limit, which is 70. We can decide to use boundary if you like, instead of using limits. Okay? in bracket n over 2, our n, which is the number of observation, which is 38 over 2, minus the cumulative frequency before the median class, which is 14, all over, okay, we have this closed, times our class limit, which is 10, everything over frequency of the median class, which is found to be 9. So going forward, we have 70 plus 38 divided by 2 is going to give us 19 minus 14, everything over 9 multiplied by 10. So here we have 70 plus 19 minus 14 is going to give us 5 over 9 multiplied by 10. So we have 70. You have 70 plus 5 over 9, or 5, let's multiply 5 by 10, and here we are going to have 50 over 9, okay? So going forward, we have 50 over 9. You can solve that using your calculator. So we are going to have 70 plus 50 over 9, because I am doing this without using calculator. We know that 50 over 10 is 5, right? So let's do that somewhere here. We have 50 over 9. 9 in 50, 9 times 5 is 45, right? So you have that as 5 point, remainder 5. So you can have that as 5.5. Okay? So because 9 in 50 is 45, remainder 5, add 0 to it, 50, so you can have 5.5. So here you have 5.5. And finally, our answer is going to be 75.5. So this is our final answer. One thing you observe with the median is that the value you are going to get here as the median value must fall within this range from 70 to 75. If it falls outside this range, it shows that what? It shows that your answer is wrong. So you can see that the median class is somehow greater than the midpoint, which is 74.5. So kindly subscribe to our YouTube channel so that you can be notified of our subsequent videos on this series, and we hope to upload more videos. In our next video, we'll be uploading videos on Hello viewers, welcome to Ajadu Math class. Today we shall continue with our statistics for beginners. This is our 4th episode on this series. Today we are going to start with the mode of group data. And in our previous videos we've been able to look at the mode for the mean, and we are able to look at the mean and the median of group data. So today we shall move straight to the mode of group data, and the formula for our mode of group data, we have that mode equals to the lower boundary, okay, LB plus F1 over F1 plus F2 multiplied by C. So we can possibly easily put this in a bracket for easy computation. So where our F1 is the same thing as the frequency of the modal class minus the frequency before it. So looking at this now, this is our frequency of the modal minus the frequency before, and also our F2 is the same thing as the frequency of the modal class minus the frequency after it. And here our C is the class width. That is, you can call it the class interval also. That means the difference between the lower and the upper. And LB is the lower boundary. So these are the parameters that we have. Now we are going to use this to compute the information given to us there. Now for us to do this, now we are making use of the same formula here. We have that our mode equals LB subscript B plus F1 over F1 plus F2 multiplied by C. So with this, our lower boundary, the first thing we are going to look at is to determine our modal class. And our modal class is where you see the highest frequency, and this is our highest frequency. So this is where our modal class is, which is 25. The highest frequency is 25. So this is our modal class, that is 6 to 10 and 25. So this is what we're going to put into consideration. And for us to determine our lower boundary, we know that our lower limit here is 6. Okay, so you are going to subtract 0.5 from this lower limit 6. So our lower boundary is going to give us 5.5. In my previous video for the median, I decided to use the lower limit directly because you can also do that. But in this case, I'm going to use the lower boundary by subtracting 0.5 from the lower limit plus F1. Our F1, don't forget, is the frequency of the modal class minus the frequency before it. And the frequency of our modal class here is 25. So let me put that in bracket for easy computation. Minus the frequency before it, which is what? 20. That is my F1. Everything over F2, which is the frequency of the modal minus the frequency after it, and the frequency of the modal class is 25, the frequency after it is 23. That is my F2. My F1, I'm going to repeat this, which is 25 minus 20, multiplied by my class width, which is 5, from 1 to 5, so which is 5. Now simplifying this further, I'm going to have 5.5 plus 25 minus 20 is going to give me 5 over 25 minus 23 is going to give me 2 plus 5 multiplied by 5. And with this, I'm going to have, and my mode is going to be 5.5 plus 5 over 7 multiplied by 5. So with this, I'm going to have 5.5 plus, 5 times 5 is going to be 25. 25 over 7 is going to give me 3.57. We can add that together. So the mode is going to be 9.07, and approximately my mode is going to be 9. So that will be the height of the student. If the height of the student is in meter or any unit the height of the student is, so we're going to have the same thing here. So this is what I just have. Okay. Now looking at this now, you're going to see that this value 9 must fall within this range of 6 to 10, just like the same thing we did in the median. If it falls outside it, then there's a mistake somewhere. So this is our frequency, the frequency for the modal class. And our final answer here is 9. Thank you very much, and please don't forget to subscribe to my channel. In our next video, we are going to move straight because we are done with the measure of central tendency. Hello viewers, welcome to Ajadi Math class. Today we shall continue with our episode on statistics for beginners. Before we proceed, kindly subscribe to my YouTube channel. So in our previous videos, we've been able to look at measure of central tendency, and today we shall proceed with measure of dispersion. And the first we are going to define here is the range. From the definition of range is the difference between the highest and the smallest numbers in a given set of numbers. Now, looking at the first example we have here, we have to find the range of this set of numbers. So from the definition of range, we know that range is the same thing as the highest number minus the smallest number. And from this observation, we can see that our highest is 20, while our smallest is what? 3. So this is going to be 20 minus 3, which is 17. So you can see that calculating range is very easy, even for group data. Just look at the observation given to you, the highest value minus the lowest value. That is the value of range. And secondly, we are going to look at the mean deviation. the mean deviation. So we're going to consider two cases for this mean deviation. And the first case is when you don't have the frequency. So here we are going to have summation x minus x bar over n. Take note, this is an absolute value. When you say an absolute value of x, it can assume two values, either the positive, that means the value of x can be positive or negative. So the absolute value only take into consideration the positive value. So that's the purpose of the absolute value for the x. Now let's consider a situation whereby we have a new data set. We are going to consider the mean deviation for this same data set, 3, 4, 8, 9, 16, and 20. So our observation is 3, 4, as we have up there, 8, 9, 16, and 20. So we are to consider calculate the mean deviation. The first thing for us to do is to calculate the mean. And in our previous video, we've been able to talk about that. Don't forget that the formula for calculating mean, which is x bar, is the same thing as the summation of x over n. That means all these observations must be added together. So we're going to have 3 plus 4 plus 8 plus 9 plus 16 plus 20. Everything over how many observations? 1, 2, 3, 4, 5, 6. We have 6 altogether. So calculating the mean of this. So we have our mean, which is the same thing as x bar, to be equals to 3 plus 4, 7 plus this, we have 15, plus 25, which is 40, plus this, which is 60 over 6. So our S bar is 10 in that regard. So using this same definition formula to be summation x minus s bar over n, so my mean deviation, I can represent that with md, is going to be summation of my x minus s bar, that is the positive value, okay, of my x minus s bar. So my x now is 3 minus 10, okay, the positive value of it. The next observation, which is 4 minus 10, plus the next observation, which is 8 minus 10, plus the next observation, which is 9 minus 10, plus the next observation, 16 minus 10, and the last one, which is 20 minus 10. So we are taking the absolute value of the observation. This is going to be over n. How many observations do we have in total? Which is 6. So calculating this now, using the value given to us there, 3 minus 10 is going to be negative 7. Taking the absolute value of that is going to be positive 7. 4 minus 10, you are going to have 6 plus 2. Don't forget, we are taking only the positive value because of the presence of the absolute value, plus 1 plus 6 plus 10, all over 6. And this is going to give us 7 plus this is 13, 15, 16, 22, 32. So here we are going to have 32 over 6. And that should give us 5.3 something. So that should be our what? The mean deviation. And what's the purpose of mean deviation? This is to see how our observation is far from the average. That is the purpose of mean deviation. Hello viewers, welcome to Ajadi Math class. Today we shall continue with our series on statistics for beginners. So today we are going to work on the variance and standard deviation for the ungrouped data. So in our previous video, we've been able to work on the mean deviation for the ungrouped data. So today we shall continue with the variance and the standard deviation. Like I told you, if we're talking about the variance and the standard deviation, this is just looking at the square difference of members from the mean of the data, the deviation from the mean of the data. So today, I'm going to give you the formula for the variance. So the first formula, if it is the population variance, we can use sigma square. Okay, we use this to represent what a variance is. So it's going to be summation x minus x bar, almost the same thing with the mean deviation we did in the last class, squared over n. So the n is the number of what? Observation. Okay, and in this case, alternatively, you can use another method for this, but for the sample variance in which we are going to work on today, we can have x squared to be equals to summation x minus x bar all squared all over n minus 1. So the only difference between these two is that here our n decreases by 1. So that's what we are going to work on today. So for this, we can have this in this form, or alternatively, it can be written as summation x squared over n minus x bar all square. Don't forget our x bar is the mean. So we are going to use these two formulas to solve our example given here. So here we are told that given the following data set 35787, find the variance and also the standard deviation. Yeah, before I proceed, don't forget also that when we talk about the word standard deviation, our standard deviation, I'm going to use STD to represent that, is the same thing as the square root of variance. So whatsoever you get for your variance, just find the square root. So that is equivalent to our standard deviation. Now for us to do this now, the first thing we are going to do, since we are calculating the variance, so our variance is going to be, let me use x square, yeah. It's going to be, let's use the first formula, x minus x bar all squared over n minus 1. So we need to calculate our S bar first. So calculating our S bar, which is the mean, in our previous video we've shown how to calculate our mean. So that means addition of everything over the number of observation, and that's going to be 3 plus 5 plus 7 plus 8 plus 7. So we're dividing everything by number of observation, which is 5. So this is going to give us 30 over 5. And our mean is going to be 6. So now making use of the formula here, which is summation of x minus x bar. So our variance will now be equals to our x, that means each of the observation minus the mean. So here we are going to have the first observation, which is 3 minus 6 all squared, plus the next observation, which is 5 minus 6 all squared, plus the third observation, 7 minus 6 all squared, plus the fourth one, 8 minus 6 all squared, plus the last one, which is 7 minus 6 all squared. Okay, we are dividing everything by our n, which is what? Which is 5. So let's use of the population variance. So I'm going back to this. So that means instead of using n minus 1, I'm going to use this in this case, because here we assume that we are working with population, not the sample in this case, because the question does not indicate whether it is sample. So we regard our information given as the population. So solving this now, here we are going to have 3 minus 6 all squared is going to give me 9 plus 1 plus 1 plus 4 plus 1 all over 5. And this is going to give me 16 over 5. Which is equivalent to 3.2. Mind you, don't forget that from here, our standard deviation, that's for our variance, right? So here, calculating our standard deviation is the same thing as saying the square root of our variance. And don't forget our variance here is 3.2. So this is the same thing as saying square root of 3.2. So our standard deviation in this case is going to be 1.79. So this is for the first method. This is for the first method. Using the second method, which has been given to us here to calculate. So we are going to make use of this second formula to calculate our variance. So here we have our variance to be equals to summation x squared over n minus x bar squared. So we want to check if we are going to get the same answer for this. So here we need to know our summation x squared first. And since the summation x squared equals, that means each of the observation square, each of the observation, that is 3, 5, 7, 8, 7, we are squaring each of it, is going to be 3 squared plus 5 squared plus 7 squared plus 8 squared plus 7 squared. So this is summation of our x squared, and that is going to give me 196. Okay, and don't forget our s bar square. So in this case now, our variance, my variance here is going to be summation x squared, which is 196 over 5, which is the number of observation, minus s bar all squared, and my x bar in this case from here, my s bar is 6, so minus 6 squared. So this is going to be 196 over 5 minus 36. So solving this further, I'm going to get 3.2. So calculating the standard deviation also is still going to be square root of 3.2, which is going to be what? 1.79. So this is for the standard deviation and also for the variance of what? Of ungroup data. Before I leave, I have to tell you this. This can be extended to when you have frequency of number. So that is, our variance, when frequency is involved, can be equals to summation f, okay, into bracket x minus x bar all squared all over summation f. So that's the only difference. Instead of using n here, we are going to use f and f here too. So those are the two formula that we have in this case. Okay, so you can use this to solve this as a classwork and put the answer in the comment section, such that when you have x and we have f, we have 0, 1, 2, 3, 4. And we have the frequency to be 3, 2, 4, 1, 2. So I want you to use this to calculate the variance and also the standard deviation. Don't forget that the standard deviation is just going to be the square root of our variance, which is summation f into bracket x minus s bar all squared over sum. Math class. Today we shall be working on episode 7 of our statistics for beginners. So today we're asked to calculate the mean, the variance, and the standard deviation for the grouped data. So the first thing we need to do is to get the middle value. And for us to get the middle value, since our class interval is 50 to 59, then we can say that our mid value will be equals to the average of the two. That is, we are going to say we are 50 plus 59 over 2. And 50 plus 59 is going to give us 109 over 2, which is the same thing as saying 54.5. So our mid value here is going to be 54.5. If the same thing is done to 60 to 69, so here we are going to have 64.5, and here we are going to have 74.5. Here the middle value is going to be 84.5. And lastly, don't forget, here the interval is from 90 to 100, so our mid value is not going to be 94.5, but instead the average is going to be 95. So that is our mid value. Okay, and looking at our frequency, don't forget that for us to calculate the mean for the group data, we have that our formula for calculating the mean is summation fx over summation f. So we need to know the summation of our frequency, that is 3 plus 5 plus 9 plus 12 plus 8, and that is going to give us 37. Okay, so now we need our fx, that means frequency multiplied by x. So using your calculator, 3 times 54.5 is going to give us 163.5. And 5 multiplied by 64.5, here we're going to have 322.5. Here I'm going to have 670.5. Here I'm going to have 1014, and here lastly I'm going to have 760. So calculating the sum of everything, that is adding everything together, the sum is going to be 2930.5. So with this, my mean is going to be 2930, which is the summation of fx over summation f, which is 37. And from this, my mean is going to be 79.2. So looking at my formula here, there's a need for me to put S bar. So don't forget that the mean is the same thing as saying X bar. That is from our previous video. I've explained the notation used for mean, so we can use S bar. So what we just need to do here is to get x minus x bar and square it. What do I mean in getting this? For the first value, it means x. My x is 54.5. That is, I have 54.5 minus x bar, which is 79.2. So I'm going to subtract this and square. You understand? So the same thing will be done for the second one, that is 64.5 minus 79.2, then squared it. So using your calculator, 54.5 minus 79.5 squared is going to give me 610.09. And for the second one, I'm going to have 216.09. I'm going to have 22.09. Here I'm going to have 28.09. Here I'm going to have 249.64. Okay, so lastly we are going to do f, and the reason why I'm doing this, from the formula of calculating my variance from our previous video, I gave you the formula for variance, which is summation f into bracket x minus s bar all squared over n minus 1, or you can say summation f minus 1, either way, or you can use n minus 1. So here there's a need for me to get f multiplied by x minus s bar all squared. So here the first value here, using my frequency multiplying it with this, so I'm going to have 1830.27. Here I'm going to have 1080.45. I'm going to have 198.81. Here 337.08. 1997.12, and the summation of everything is going to give me 5,443.93. You can use your calculator for that. 97.12, and the summation of everything is going to give me 5,443.73. You can use your calculator for that. So calculating my variance in this sense shows that the summation of f into bracket x minus s bar all square gives me 5,443.73 all over summation f, which is the same thing as 37 minus 1. Okay? And with this shows I'm going to have over 36, right? So dividing this gives me 151.2. And lastly, we have to get variance and the standard deviation. So our standard deviation, from the last video, we know that our standard deviation, SD, is the same thing as square root of our variance, which is the same thing as square root of 151.2, and my standard deviation is going to be 12.3. So that's it for the group data. So kindly subscribe to my YouTube channel. In our next video, we are moving to more important topic in statistics. Until then,